One formula that relates a person's maximum heart rate in beats per minute to the person's age in years is R equals 220 minus A. Determine the interval in which the person's heart rate is from 50% to 85% of the maximum heart rate if they are a 21-year-old. Okay, so for a 21-year-old, the maximum heart rate will be 220 minus 21, which is 199 beats per minute. If we're looking at an interval from 50% to 85%, then we will just take 50% of 199, which is approximately 100 beats per minute, and 85%. To write as a decimal, you just divide the number by 100. 0.85 times 199 is 169 beats per minute. So your interval would be from 100 to 169 beats per minute. As a repeat, if we change to a 40-year-old person, the max heart rate for a 40-year-old would be 180. 50 to 85%, that interval of 180 as your max. 50% of 90 is, 50% of 180 is 90 beats per minute, and 85% of 180 is 153 beats per minute. So no matter what age they give you in WebAssign or your online platform, you subtract your age from 220, and then you multiply by the decimal forms of these percentages. You're considering two job offers. The first job pays $11.25 per hour. The second job pays $10 per hour plus 25 cents per unit produced per hour. How many units must you produce per hour for the second job to pay more per hour than the first job? The first job is just straight up $11.25. That's what you're going to earn in the first hour. The second offer, they will pay you $10 plus 25 cents for every unit you produce. Let's solve this for x. Subtract 10 from both sides. That leaves us with $1.25 equals 0.25x. Divide both sides by 0.25. And as long as we make more than 5 units per hour, the second job will pay more than the first job. The revenue from selling X units of a product is R equals 111.98X. The cost of producing X units is C equals 92X plus 760. Profit is revenue minus cost, the money coming in minus the money going out. You turn a profit or you obtain a profit anytime profit is positive or revenue is greater than cost. There's a couple ways to decide what production rate will return a profit. One way is to set up your profit function. That's to take function R and subtract function C from it. So we have revenue minus cost. The cost function has two terms in it, so we have to be careful to subtract both terms. Combining like terms, 111.98x minus 92x is 19.98x. Minus 760 from the distribution, that's a different term. It's a constant, so we're just going to drag it along. Profit is obtained when that's greater than 0. Add 760 to both sides, divide by 19.98, and you will get X greater than 38 units. So as long as there are more than 38 units produced, a profit will be obtained. Another way to do that, and it's a short and sweet version, is just make sure revenue is more than cost. So you can set revenue greater than cost and solve for X that way. You will actually fast forward to this line here. But I like to show you more than one way when I know more than one way. Let's try again. The revenue from selling X units of a product is given. The cost of producing X units is given. To obtain a profit, the revenue must be greater than the cost. So this time we're going to try the short and sweet way. We're going to take our revenue function and make sure that it's greater than our cost function. Money coming in is greater than money going out. Subtract 11.8 from both sides. You will get 10.87x. That's still got to be greater than 200,000. Divide both sides by 10.87, and as long as we are producing more than 18,399 units, we will obtain a profit based on the equations given.